Okay, so now we're told about a syringe full of air, so a fixed mass of air, where they are varying the volume. So when the plunger is pushed in, the pressure in the syringe increases, but the temperature remains constant. We're asked to explain why that pressure increases. So the first thing to think about is by reducing the volume, so by bringing this piston in here, we are reducing the volume. So if we think about the molecules in our gas, we know that they are ordinarily very far apart and they're moving randomly in different directions and with different speeds. But as soon as we reduce the volume that they've got, we find that those air particles have to be moved closer together. So the air particles are closer together. Now what that means is, as they are moving around in that space, they are colliding with the walls of that syringe and each other, and that is what's exerting the pressure. But if they have now got less space to move around in, then what's going to happen is the collisions between them and the walls are now going to be more frequent. And it's really important that you say more frequent or more per second. It's not just that they're more. And the other thing is, when these particles are colliding with the walls of the syringe, they're exerting a force. But if you now look at the area that we've got, by reducing the volume, we have now got a larger force, but it's being exerted on a smaller area. And because we know pressure is force divided by area, if we have made our area smaller, then that is going to increase our pressure. Then we're shown a particular type of syringe that is used to start fires. And we're told that when the air is compressed really quickly, the temperature of the air increases. How does an increase in temperature affect the air particles inside the piston? We've got to choose one. So does the mean kinetic energy of the particles increase, the mean potential energy, or the mean separation? Now, if they're having less space, then the separation can't possibly be increases, so it can't be the last one. The potential energy of a substance is affected by the positioning of the particles. It's not affected by temperature. And that means that the answer must be the kinetic energy increases, because an increase in temperature causes the particles to have greater kinetic energy. So when the air is hot enough, a small piece of cotton wool in the piston will catch fire. The energy transferred to the air in the piston is 0.0130 joules. The mass of air in the piston is 2.6 times 10 to the minus 8 kilograms, and we're told the specific heat capacity of the air is 1.01 kilojoules per kilogram per degree C. So we are now asked to work out the temperature change in the air. So what we need here is we need our formula from our formula sheet, which says that the change in energy is equal to the mass times by the specific heat capacity times by the change in temperature. So if we rearrange that, we have to firstly make our delta theta the subject, so we have delta E over m times c. Now the other thing you need to spot here is our units. We know that energy should be measured in joules, but we can see our specific heat capacity is measured in kilojoules. So firstly, we have to then convert those kilojoules per kilogram into joules per kilogram. So actually our value for C is 1010 joules per kilogram per degree C. When we then plug that in, we take our energy of 0.0130, we divide it by our 2.6 times 10 to the minus 8, multiplied by our 1010, and that gives a value for the temperature change of 495 degrees